Welcome, 8th graders. Can you guess where we are? We just decided we're going to check in and see what's going on with Mr. Lowe.
Hey, Mr. Lowe.
Mr.
Hey guys, how's it
Lowe.
going?
Good.
Good. Wow. What are you up to?
Well, I don't have to chase 8th graders around anymore. So, just crushing some Takis. Gonna move on to my Cheetos. Sticking with my Toes diet. Cheetos, Tostitos, Doritos, Taquitos.
Sounds
Wow.
that stuff.
Sounds
I
pretty
see.
healthy.
Distance learning's been kind of rough, huh?
Well, you know, I've just been kind of hanging around, sticking with the food groups. Hey, I got a question.
Yeah.
You guys want to burn something?
Oh,
Yes.
that'd be awesome.
Should we maybe burn these Cheetos and see how
Yeah,
they go?
before you burn through them, right?
Yeah, well,
Ah.
I'm gonna burn through them, or you're going to.
Yeah.
Let's do it.
Yeah, let's do it because we have time right now.
We do
too,
have time.
And we're looking for something to do.
All
Come on
All right,
down
let's
to the
go.
lab.
Let's
Sounds
go.
like
All
good stuff.
right.
All right, you guys. When your boss, Mr. Lowe, tells you to go burn some cheese puffs, you got to burn some cheese puffs.
That's right.
So here we go. Let's see what happens when we light this one on fire.
Ooh, this is gonna be awesome.
So cool.
I wonder if it will even burn.
That's a good question.
They're kind of fatty or greasy. So
Greasy, yeah.
It seems like it would.
Oh man, it's getting close to my fingers.
Ooh, look at that.
That is so cool.
That is so awesome.
Oh, it's like a little mini bonfire.
Ooh.
Oh man, look at that. It even fell off.
Wow.
It's still giving off a lot of heat,
Look
Mrs.
at
Von Eschen.
that. It's keeping your hands warm.
Sure is.
Good thing we have our nice fireproof lab tables.
That's right.
So, as you're feeling that heat, it would be really interesting if we could capture that heat somehow
Yeah.
and measure it.
I bet there's a lab we could do about this, don't you think?
Yeah, I just have a feeling there probably is.
I think you're right. Let's
Okay.
check our INB.
Okay. Okay. Well, we're about ready to follow through with what Mr. Lowe said and burn some Cheetos. Turn to page 24 in your IMB. You'll find a lab called Heat Transfer and Calories. Let's read the background. You will recall from Unit 3 that the more mass an object has, the more heat it has contained in it. For example, an apple has more heat or calories than a single grape because it has more mass. Heat is released from food when it is burned. The amount of heat released is measured in a unit of heat known as calories. Today, you, or all of us together, will be burning a cheese puff and measuring how much heat or calories it releases. Okay, so the problem is how much heat, energy, or calories can be released by burning a cheese puff. Hi, Mrs.
All
Anderson.
right. Hi, students. Welcome. I'm so excited to burn stuff today. This is great. Mr. Lowe is so fun. He has such good ideas, don't you think?
Yeah.
All right, so for your hypothesis, you guys, notice we've got just a little blank to fill in here. It says, a cheese puff will release blank calories of heat energy. So I know that many of us want to connect the word calories to food, but remember in Unit 3 that calories are the unit of heat. So we're thinking about heat calories that one cheese puff will release when we burn it. Now, this might be hard to think of a number, but that's okay. Just give it a guess. Think about what you know about cheese puffs, what you know about burning things, and put a number in the blank.
Mrs. Anderson, can I just see a cheese puff? I just kind of
sure.
want to see what it looks like just to remember.
Yeah. So here's a single
That's
cheese puff.
one
Yeah.
cheese
We're
puff.
just
Okay.
talking about one puff.
Okay.
All right. Already my fingers are dirty.
Yeah.
Okay, so now let's introduce you to the equipment for the lab today, and then we're going to get you some data to start filling in your data table, okay? So we are going to be working with a really cool tool today called a calorimeter. A calorimeter is a tool that measures the calories of heat, so we call it a calorimeter. And here are the parts to it, okay? Now, this metal cylinder has a lid on it, and it has this little plastic ring We're going to be putting this glass flask inside there. It'll have a little bit of water in it. And then we're also going to be working with just half of a cheese puff because a whole cheese puff won't fit inside our calorimeter. So we're just going to use half of a cheese puff today. Now, when you look at your data table on page 24, notice that we have 2 trials, but today we're going to be really accurate and only need to do 1 trial. So you can cross off the whole column of trial 2 in your INB. Just draw a big X through all of that. Very good. Super. Okay, now here is some data to record in your data table right now for trial 1. You're going to be recording the mass of all these parts, and we've already placed them on the triple beam balance and recorded the masses for you, and you can see them on these cards, okay? So this metal thing, this is the calorimeter. Please record that it has a mass of 157 grams. Now the specific heat of the calorimeter is already filled in for you, 0.055. The next spot is the mass of the flask. So this is our flask. Please record its mass of 92 grams. In your data table, the specific heat of the flask is 0.2, already recorded. Next, the mass of your water. So you can see in my graduated cylinder, I have 10 milliliters of water. And we remember that in the metric system, water's volume is equal to its mass. So 10 milliliters has a mass of 10 grams. Please record that number. Remember, we've already learned that the specific heat of water is 1. So in the next section of your table, please record 1 calorie per gram degrees Celsius for water specific heat. Next up is the mass of our food. And because I broke the cheese puff in half, we recorded this as a mass of 0.5 grams. All right. Okay. Now I'm going to assemble all of these things together and then we'll measure the starting temperature of the water. So I'm going to get my thermometer ready.
While Mrs. Anderson is getting her thermometer ready, this is what your data table should look like so far. And then remember, we did cross out trial 2. So right now we're going to get the temperature of the water.
Yeah. So to put all of this together in my calorimeter, I'm going to take this lid off and I'm going to put it over the flask and then replace this yellow piece so that I can pick it up and suspend it so that it's kind of hanging from the top here and it's not touching the bottom. Next, I'm going to pour my 10 milliliters or 10 grams of water into the flask. And then I'll take my thermometer and place it down in the water, and we'll give it a few seconds to read the water's temperature. Now, while we're waiting for the thermometer, I'm going to show you how we're going to get the cheese puff ready. We have this little cork with a pin sticking out of it, and we're going to take our cheese puff and put it on this pin like so. Then, in a little bit, once we're ready, we're going to light the bottom of the cheese puff on fire. We'll cover it with the calorimeter. And as the cheese puff is burning and releasing heat, it's going to release its heat to the metal parts, the glass flask, and the water inside it. So 3 different things are going to be absorbing heat from the cheese puff. And we'll see that in our calculations on our next page. Okay, so our TS starting temperature is 21 degrees Celsius. Excellent. Okay, we'll be back with you for the burning of the cheese puff. All right, you guys, now is the time to light the cheese puff on fire.
Woohoo!
So come on in a little closer, Mrs. Von Eschen. Okay, so with my match, I'm going to hold the match here in this space so that the fire will hopefully burn up all of the cheese puff. And as soon as I make sure that it's lit, then I'm going to cover it with the calorimeter, okay? So here we go, everybody. There's my match. Holding it down here in the middle. It is on fire. So now we'll cover it.
Oh, it's really burning.
Is it really burning? Good.
Yes. It looks awesome. That's
You
a
can
lot of heat in there right now,
Yeah.
everybody.
You can see
you
it's
see the
giving off a
smoke?
little smoke coming out here, and it smells pretty bad.
Ooh, yes. You're missing all this stinky stuff.
Now-
Look at that.
Cool. Ooh, I can tell already the sides of the calorimeter here are warm. So heat from the burning cheese puff is being absorbed by the calorimeter here. I can see that the temperature is going up. Yeah, it's climbing quite quickly. So heat is being absorbed by the glass flask and by the water. So there's heat going into multiple parts, all 3 parts of this calorimeter system.
And even though you don't see the cheese puff burning anymore, it's still releasing a lot of heat.
Yeah, look at all that
Because
smoke.
look at all this smoke and
So I'm just gonna stir the water around here and make sure we're getting all the heat possible. Still going up, so we'll give it another just a couple seconds. Ooh, it smells really bad, you guys.
really bad.
All right, it looks like our temperature has stopped increasing, and it says 71. 71 degrees Celsius is our TF. And that means our delta T would be 71 minus 21. So that's a delta T of 50 degrees Celsius. Wow. That's a big delta T.
That is awesome. Oops. 50 degrees.
All right, so trial 1's data should be all filled in now. And the next thing you'll do is watch a screencast to work through some of the calculations to figure out how much heat was released by the cheese puff to cause the temperature of all 3 parts to go up so high.
Hey, Mrs. Anderson.
Yeah.
Now that we've burned this cheese puff and it looks, I don't know, not very good anymore. But I have a feeling that Mr. Lowe would still want to eat it. Should we bring it to him?
Yeah, let's
Okay,
do it.
let's do it.
Students love to eat this at the end of the lab too, so
Yeah.
I bet Mr. Lowe would like that.
Okay,
Yeah.
let's do it.
Okay.